So now from the slides, we know that we've got our 3 conversion factors. We've done Avogadro's number and molar mass, and now we're dealing with molar ratios. We described how to get those molar ratios from the subscripts of a chemical formula. So an example, A sub X, B sub Y, we know there are X moles of A for every Y mole of B, for every 1 mole of the whole compound. Okay? So we're going to use that information to work some problems. And we'll also combine it with some other conversion factors so that we can see how we can use them in conjunction. Okay, let's start with this first one. How many carbon atoms and hydrogen atoms are in 0.2 moles of ethane? And it's the formula for ethane. Okay. Now, first of all, like all of our word problems, we're going to pull out that information before we get started. So it's asking for how many moles of carbon and how many moles of hydrogen atoms there are, and it gives us 2.5 moles of C2H6. Okay? So we want to remember that C2H6 is our compound, and we've got carbon and hydrogen are part of that compound. So for every 1 mole of our C2H6, we get 2 moles of our carbon, and we have 6 moles of our hydrogen. Okay? You can take any 2 of those and make them into conversion factors. So that's exactly what we're going to do. Okay? We've got moles of the ethane. We want to get rid of moles of ethane. So that's what we're going to put on the bottom, moles of the C2H6. We are asked for, let's do the first problem first, moles of carbon. We're going to put moles of carbon on the top. Now we have to figure out what the ratio is here. We have 1 mole of the whole thing, so that's 1 of those, to 2 moles of carbon. So that's 2 of those. And then we can do the calculation. These guys cancel out. And we end up with 5 moles of carbon. We check our significant figures. We have 2 significant figures here. These are exact numbers, so we need 2 significant figures in our answer, which means we need to put the point 0 in there. This is our final answer. Now, do keep in mind, it asks us for 2 different things, moles of carbon and moles of hydrogen. So that's why we pulled out 2 question marks. So don't just leave a problem there and forget to answer the second part. Sometimes there will be multiple questions within the same question. So make sure you get all your answers. Okay, we're going to start off with the same thing we started with before, 2.5 moles of our C2H6. Only this time we're going to go to our moles of hydrogen. So again, we need moles of our C2H6 in the bottom to cancel out. What we want to get, we put on the top, 1 mole of this to 6 moles of hydrogen. 6 moles of hydrogen. And so we do this multiplication and we end up with 15 moles of hydrogen. Check our significant figures before moving on. We have 2 significant figures here. Those are exact numbers, so of course we need 2 significant figures here, and we have 2 the way it's written, so we're all good. So here's a second answer to that problem. So hopefully you see how to use these molar ratios as conversion factors. Now we have another problem that we're going to work with, and this time we're going to use our molar ratios. We're going to combine it with some of our other conversion factors that we had up there. Show you all those. So we're going to combine them. I'm going to erase that last problem we did so that we can focus in on this new problem and have less to distract us. Okay. Now the new problem reads, calculate the number of sodium ions in this many grams of sodium sulfate. So I'm going to pull out the information first of all. So we have a question for the moles of sodium ions. How many moles of sodium ions? What we're given is that we have 5.63 grams of sodium 2SO4. So we need to get from here all the way to there. So let's go ahead and do our logic. Think about our logic. We've got grams of sodium 2SO4. Well, we can rarely do anything with grams. Remember, the first step is generally to turn that into a mole. And we can do that because we know our molar mass, right? We're going to use our molar mass to convert this to moles of sodium 2SO4. And then you'll notice that the sodium that we actually want here is a part of the larger whole, the sodium sulfate. So there, we're going to use our molar ratios to get moles of sodium on it. Okay. There's our logic. Now let's actually go about doing it. We said we're going to need molar mass of the sodium sulfate. So let's go ahead and do that over here. We've got our periodic table, and we're going to need 2 of the sodiums. So we're going to take 2 times 22.99, and then we're going to have to add a sulfur. Come over and look at our sulfur. It's 32.07. And then we're going to add 4 of our oxygens, 4 times 16.00. And we add those together, we get 2 times 22.99 plus 32.07 plus 4 times our 16. And we end up with 142.05. And this is molar mass, so what are units? Grams per mole. Oh, it's grams per mole. It's 1 mole. This is for the sodium 2SO4. Okay. So let's go ahead and use that in our problem. We've got grams of sodium 2SO4 on the top. So where do they have to be to cancel out? Well, they have to be in the bottom. So let's go ahead and put the grams part of our conversion factor in the bottom. 142.05 grams of sodium 2SO4. Now the thing on the other side of the line, our conversion factor has to go on the other side of the line. So the moles have to come up here. 1 mole of sodium 2SO4. Alright, we cancel those out. Now we're at moles of sodium 2SO4. We've already stopped the problem there. We know that's not what we're looking for. We have to do another step with molar ratios. So we want to cancel out this moles of sodium 2SO4. So I'm going to put that in the bottom. Sodium 2SO4, sodium sulfate. And then we want to go to moles of sodium. So I'm going to write that in top. Moles of sodium ions. Now from the chemical formula, let me just rewrite that chemical formula so you can see it really big. We see that there are 2 moles of sodium for every 1 sodium sulfate. So we've got 1 sodium sulfate, 2 sodiums. Now those will cancel out. The only thing we didn't cancel out now is our moles of sodium ion. So let's go ahead and do that problem. 5.63 times 1 times 2 divided by 142.05 divided by 1. And we get, from our calculator, we're going to get 0.079267 and so on. What do we have to do before moving on to the next problem? Significant figures. Always significant figures. So we have 3 significant figures here. We've got 5 significant figures here. That's an exact number, that's an exact number, and that's an exact number. 3 and 5, the lowest is 3, so we need 3 significant figures here. Go ahead and write that so that I know, even if you make a mistake on the significant figures, that you were trying for that. Let's go ahead and count them. 1, 2, 3. Those are significant. Remember, those leading zeros are not significant. so we don't start there. We go to the one next door, and we see that it's 6. That's above a 5, so we're going to round up. So the answer is 0.0793 moles of sodium ion. And that is our final answer. Okay. So do make sure you're very comfortable with using those subscripts to get molar ratios. Now, there is, if you go back to our list here, there is another way to get molar ratios, and that's the coefficients of a balanced equation. We're going to talk about that next, and we'll do some problems in the next video.